everyone. Welcome to another amazing session that is about to happen. We have here Vadim. Hi, Vadim. If you'd like to turn on your video camera, what I will do is make you the host while Kanthi is joining.
Yeah. Hi, Ryan. Do you hear me? Yes, please.
Yes, I can hear you perfectly. I just made you the host. So if you'd like to turn on your video and...
Yes. Wonderful.
Awesome.
Do you hear me?
Yes, perfect. Perfect. So for everyone who's joining, welcome again. Kanthi is having an issue with the sharing the slides, so I will take over and share the slides on screen. So you should be able to see my screen very soon when I share. So let's start the session by introducing each other.
Yeah. Hi, everybody. Yeah, I'm Vadim Tkachenko, CTO at Percona, and in Percona we provide software and services for MySQL, PostgreSQL, and MongoDB. And today I will talk with Kanthi a little bit how we can integrate MySQL with the ClickHouse and why we would want to do that.
Awesome, thank you. Kanthi, your turn.
Hey, my name is Kanthi. I'm an open source contributor and dev advocate at Altinity. I've been focusing on the replication projects, so replicating different data sources to ClickHouse.
Awesome, thank you. So I am trying to share my screen. One of you tell me if you see my screen when I do share. Okay.
It was for introduction, which we already did. So I guess we go to next slide.
Okay.
Where I will talk a little bit about MySQL strengths and what is good MySQL for. And of course, I'm in the MySQL world. I imagine that everybody knows what MySQL is good for, but in case you're not in my world, so MySQL is a very popular, very fast LTP database, or we name it also operational or transactional database, which is designed and used to process transactions very quickly and very fast, and to do it in a very high concurrent environment. MySQL can handle literally thousands of concurrent transactions, and at the end it can handle up to 1 million transactions per second, which gives users very good experience in response time and very quick transactional turnaround. Next slide, please. Right. And yes, that's what makes MySQL good for. It is very good for ACID transactions. That's to provide excellent transactions capability and isolations level. It provides a great concurrency. Like I said, it is very fast for point queries. Like if you need to look up someone by, say, first name, last name, or by phone number, MySQL is very fast and very capable for that, and very good for very short transactions. So MySQL is an excellent tool for build LTP applications. It's basically all kind of online properties like e-commerce, web shop. I know MySQL you used for online gaming, and we know that MySQL is used to build social networks, websites. So again, everything that requires very fast, very quick feedback for users. When you go to some website, when you click on a web page, you want to get response within 1 second, or you will basically leave to another website. So that's MySQL is very good to provide this kind of experience. Next slide, Ryan, please. And but there comes another side of MySQL. If you run a lot of transactions per second, say like 1,000 transactions, and at the end you end up with very big data sets, like millions or tens of millions or billions of rows, then eventually you would want to run some analytical queries for that. For example, to see what is, say, average order size or how many users visited your website, say from North America or from Europe or from any other region, to not discriminate any other. And this is where we will want to run some aggregation queries, like with group by, with filtering. And this is where MySQL might be actually quite slow and not very good at. So analytics with MySQL can be used only for very small data sets, let's say up to 10 million rows. After that, running more interesting reporting or aggregating queries will be quite problematic for MySQL. And there we can show some examples. Next slide, Ryan, please. So, for example, one of my favorite data sets it is on-time airline departures data set, which I used previously, and you can find on our Percona blog post. And this is also contains all smaller records from all the airline departures and arrivals inside the United States. And if we say want to run some aggregation queries, for example, in this case, we want to find amount of delays, where a delay defined by 10 minutes or later, and group by by delays per week, and order by amount, and whole data set is over 170 million rows. And if you run this query, for example, on MySQL, on our hardware, MySQL, it will take over 9 minutes to process. And then when we compare with ClickHouse, for ClickHouse, it will take only half a second to return result of this query. And the next slide, just another quick example, also quick aggregation query calculating average by average delay by year. So we do group by component and do aggregation function average, and again processing over 170 million of rows. For MySQL, it takes 4 minutes to process this data set, and for ClickHouse, again 0.674 seconds to handle this data set. Next slide, please. And a little bit to explain where this difference comes from. Maybe some of you are familiar with column store databases, and this is how data is processed in ClickHouse. So MySQL features storing data in the rows, and this is what gives benefits for MySQL for quick processing data in single rows. Also, MySQL processes data in single threaded queries. That makes it optimal for high concurrency, where multiple users running each single thread will be able to access data very fast. But that's exactly opposite what is needed for computer aggregates on layer 2 data set, which is ClickHouse is designed for. So ClickHouse stores data in columns. It has optimization for very fast I/O processing, computes, aggregates very efficiently, and more importantly, in parallel. So that's a big difference between MySQL and ClickHouse, why we see that a dramatic difference in query response time. Next slide, please. And yeah, this is to show how data organization between MySQL and ClickHouse. Like I said, MySQL, when you need to read even a few columns, it will read all columns in a row. And for ClickHouse, if you need to read only selected columns, ClickHouse will be very efficient to access only needed columns in a data set. Next slide, please. And that's where we can see, for example, on this hypothetical queries which we run. And for example, if the whole data set takes 59 gigabytes, MySQL will need all columns and the whole data set, all 59 gigabytes. And in contrast for ClickHouse, next slide, please. So for ClickHouse, for example, if you need to read only 3 columns will take only 3% of data, 1.7 gigabyte, and even ClickHouse compresses data very efficiently. That compressed data result in 121 megabytes. And given that ClickHouse is able to read all data in parallel, for example, in 8 threads, so each thread will read only 2.6 megabytes of data in parallel with other threads. That's what will give a result, and with that what allows ClickHouse to retrieve data very fast in this case. Next slide, please. And why you would ask why would not we use ClickHouse then for everything? But this is where we see great synergy between 2 different databases, because this is where ClickHouse has some weak points, where MySQL has strong points. This is where we see this complementary use case beneficial for both worlds. So like I said previously, MySQL is great for very quick transactional processing, but ClickHouse does not support ACID transactions. And MySQL very fast for single row updates, while single point queries can be very problematic for ClickHouse. Still, if you need to update only single row, ClickHouse will need to read and update a lot of data. And high concurrency user access, very good for MySQL. MySQL, you will be able to handle a lot of concurrent queries, where ClickHouse is more designed for a single kind of a query use case, where single query will use a lot of resources in background in parallel, which makes it a ClickHouse not very good for concurrent access use cases. Next slide, please. And this is where I pass it to Kanthi. Kanthi, can you take it from here?
Yeah, I got it. Thanks, Vadim. Yeah, so thanks, Vadim, for talking about kind of the pros and cons of using ClickHouse as an analytic engine. And the next set of slides, it's mostly about our experience and our lessons learned, trying to do an ETL from MySQL and ClickHouse, and we're just going to share some of the tools we have developed with our customers, and kind of the best practices to do the data transfer. So let's assume that you are part of the database team. You've convinced your peers to use ClickHouse as your analytic engine. The first step you'll probably do is identify the databases and the tables in MySQL that you want to be replicated in ClickHouse. So it could be a subset of everything you've got in MySQL, or it could be the complete database. And then the next step is you would want to create the same the schema and the databases in ClickHouse, because unfortunately you can't do a copy and paste from MySQL and expect it to run in ClickHouse. And then after that is set up, you would want to start the transfer. So actually, next slide, please. So this is kind of the architecture of how everything is set up. For you have your MySQL analytical database. So the problem is before you start transferring data, it's obviously your transaction database. It's not going to be empty. It's going to be big, and you want to be able to transfer that data into ClickHouse. So you need something faster, especially if it's in terabytes. Debezium does have its own initial snapshotting or initial dump functionality, but unfortunately that's very slow. So one of the first steps you want to look at is maybe to use a dump and load tool that's way faster. And then you might want to validate the data. And then the third step would be you would actually set up the CDC replication. So any event that comes into MySQL, you want that to be replicated in real time in ClickHouse. Next slide, please. Yeah, so to kind of summarize all the steps you would normally go through is, as I explained in the previous slide, do the initial dump and load of the terabytes of data, or even bigger, to ClickHouse, validate the data as a second step, and then you would want to use a sync connector or something similar to set up the CDC replication. Next slide, please. So why do you really need the custom dump and load? The main reason is because, as you can see on the table on the right side, the data types are not the same across between MySQL and ClickHouse. So you have to do that mapping from MySQL into ClickHouse, and then the limits on the data types are not the same. For example, some of the problems we'll see is the MySQL date field. The min is actually 1000 and then 9999. But on ClickHouse, it's different. So you want this tool to actually convert your limits from MySQL and transfer it into ClickHouse limits. The other main reason is you want to be able to read the MySQL schema and then create the ClickHouse schema. So there's a couple of steps you want to do is you want to start for the primary key. We actually use a replicated merge tree. So you want to be able to define a replicated merge tree in your create table schema and define the primary key in the order by columns. And also in the future, maybe use partition information from MySQL and define that in ClickHouse. And finally, yeah, you definitely need something really fast because yeah, you definitely don't want to wait for days to complete the initial transfer. Next slide, please. So this is some of the work our customer actually did, and credit to Arno especially. We looked at a few dump tools. This is a good comparison that's actually done by Oracle of comparing some of the tools that are available to do a dump of MySQL. So you'll actually see they compare MySQL shell, MySQL dump, and then MyDumper. And you'll see that MySQL shell actually is faster, and in our testing we found that it's more accurate compared to the other tools. Next slide, please. All right, so yeah, so our setup of actually doing the dump and load as these following components. So we use MySQL shell. Some of the benefits are it's multi-threaded. You can we'll actually get to the command in the next slide, but you can actually pass the number of threads. So MySQL shell takes the primary key or indexes and then splits that data across multiple threads in the dumping process. So it's way faster to dump the data into SQL files. And then the next step is we have a Python tool that actually wraps up ClickHouse client. So what it does is it's actually able to read the SQL files and create the ClickHouse schemas. by kind of inserting all the ClickHouse necessary syntax that's required. And then also it loads the data using ClickHouse client. ClickHouse client is also multi-threaded and it can read compressed data. So it's as fast as MySQL shell in the loading process. Next slide, please. So yeah, this is some of the, we've actually documented this in our GitHub project. I would recommend installing MySQL shell if you're on Linux to use the apt-get tools and not to use Snap. Snap actually uses Python, which kind of works differently. The apt-get uses JavaScript. And so the syntax is you would use MySQL, you would point it to the MySQL databases. You can dump the table separately, or you can dump the schemas. You would provide a directory, a destination for the dump files. It dumps the schema along with the data. And then you can actually specify the number of threads. So we've tested using like 88 threads, and it's fairly fast. So after that, after you're done dumping your SQL files into a destination, you can use the ClickHouse loader tool, point it to your dump destination, and then pass the parameters for the ClickHouse database. You provide the database name, the username, and the password. And then this would load. First, it'll create the schema. So if you can go to the next slide, please. All right, that's fine. Yeah, I think this one, this is fine. But I'll just talk. So yeah, so ClickHouse loader would create the actual table with the ClickHouse syntax, and it'll load the data into ClickHouse. So so that kind of finishes our first step of doing the initial dump and load. So the next step you want to do is you might want to validate data, because doing a select count across the database, across MySQL and ClickHouse isn't necessarily the best way of making sure that the data is correct. Especially, example, if your data is driving a dashboard and the number of rows might match, but then the data might actually be different across the databases. So one of the tools that Arno actually created is based on Sisen's article. They actually use MD5 to create a checksum of each row. But then we need to have additional logic, because as we talked about in the previous slides, the data limits are different. So your data and MySQL and ClickHouse are going to be different. So you have to add extra logic to make sure the checksum is the same for the different limits. And that's what this tool does. It's called MySQL table checksum. As it's says on the right, it creates, there's one utility that creates the checksums for MySQL, and there's another one that creates the checksum for ClickHouse. And then essentially you just want to differ to make sure your checksums match. Next slide, please. All right, so after you've, so the first step is you've done the initial dump and load. Second step is you validated the data. Now you're all set to start the replication. So there's a couple of ways you can do it. You can obviously start MySQL, but you can't obviously start some of the transaction databases. So one other way you can point, so you can actually note down the last row where you stop the initial dump and load. You can actually note down either the MySQL bin log position along with the binary log file, or you can note down the GTID, and you can actually set up the vSIM connector to start the replication from that specific point. So it's quite a few steps. We actually have them documented in the following link. But after that is set up, you can start the MySQL connector and the sync Kafka connector, and that should enable the real-time or near real-time replication. Next slide, please. So yeah, the next step is you want to be able to deploy it to your, assuming that you're doing this in some sort of a staging environment, and you're happy with everything. Now you want to be able to deploy it. Actually, so we have different support different environments. We support Docker Compose. We also support Kubernetes. So we use Strimzi as our controller for managing Kafka connectors on Kubernetes. So we actually publish both the MySQL Devops Strimzi connector and the sync ClickHouse sync Strimzi connector. It's publicly available in Docker Hub. And the other way you can actually deploy it is you can use the conventional way of copying over the jar file into your Kafka Connect binaries, and then just start your Kafka Connect application. Next slide, please. All right. So so after you've deployed it, you obviously want to be able to monitor it, and this actually, this whole Grafana dashboard actually comes from a lot of inputs from our customers, so some of the metrics we monitor are lag, which is really critical. So one of the problems you could see is either your Devops connector is lagging, it's either slowly processing your bin log files, or your sync connector is slow in processing topics, data from the topics. So you could actually measure the lag both on the Devops side and the sync connector side. Some of the other problems you see is you would see that the connector fails either through out of memory, which is some of the other common issues you would see. You want to be able to actually monitor Kafka. So we also bundle the Grafana dashboards for Kafka and the Devops source connector. Next slide, please. All right, so we're just gonna, so now that we've kind of talked about all the lessons learned and some of the tools we have actually developed in going to production with the sync connector, we just want to talk about a couple of design challenges that we faced. One is the MySQL master failover, and the other problem is how do we handle schema changes, which is really not straightforward in the Kafka Connect framework. Next slide, please. So this is kind of the normal setup where you would have the Devops connector pointing to your MySQL replica, and then your Devops reads the MySQL logs, dumps it onto Kafka, and the sync connector reads the messages from Kafka and writes it to ClickHouse using the ClickHouse JDBC library. So we've talked about this before, is the sync connector, because ClickHouse doesn't out of the box support updates and deletes, our way of supporting it is by using the replacing merge tree and adding two columns. One is the version column, the other one is the sign column. So in case of deletes, we would set the sign column to -1, and then you can actually set up row policies where you can hide the rows where the sign column is -1. So that's the way of handling deletes. And for handling updates, what we do is we take the transaction ID part of the GTID from MySQL, and we assign that to the version column in the replacing merge tree. So in this case, so for example, if the row 23 was the original row, And then if that row was updated, the new version number would be 24. And as part of the replacing merge trees merge process, it'll drop the row with version 23 and it'll retain the version, the row with version 24. So in the back, it just looks like an update, but in reality, there's a compaction process that runs in the background. Next slide, please. So this is one of the problems that one of our customers raised is when you have a scenario of MySQL failover, when your primary fails over into your standby server, the original process of passing the transaction ID might not work. So the reason is, if you look at, this is just an example. So for example, if you have record 1 in the original primary, the transaction ID is 23. On the standby replica, the transaction ID might be a lower value. So what happens is, after the failover, if we end up passing that same transaction ID as a version column for replacing merge tree, then ClickHouse is going to drop the wrong row. So the challenge is we need a monotonically increasing number so that ClickHouse can drop the rows properly. And so our solution was to create our own Snowflake ID. Sorry, if you can go to the next slide. So we came up with this kind of a modified Snowflake ID where the first 41 bits are the timestamp. The timestamp actually comes from the MySQL bin logs, and the second part would still be the transaction ID. So even if the transaction ID works out to be a number that's lower than the previous replica or master's transaction ID, we're always guarantee that the timestamp will be increasing, and that's how we guarantee that it's a monotonically increasing number. Next slide, please. Okay, so the other problem we noticed is how we handle schema changes. So there are some schema changes we can handle within the sync connector. So Devops creates events, and also we get the schema. But there are some events for some DDL changes that we cannot handle. So that's actually a limitation of Devops. So yeah, so one problem we have is the limitation of Devops. The other problem is the other problem is the trade-off between parallelism and consistency. So this is just an example of where you can get an update table record from MySQL, and then say you get a truncate table in that specific order from MySQL. But then when the MySQL connector writes it into Kafka, it might actually end up writing that in 2 different partitions. And as you might know, Kafka only guarantees order of messages within a partition. So if it ends up in different partitions, when the consumers read it from Kafka, it could actually be out of order. So that's what this box on the right explains, is the sync connector could actually end up processing the truncate first, and then actually persist the truncate, and then the update employees might be executed after that. So the problem is we'll never get the update, and we'll end up dropping the table. Next slide, please. So yeah, so just to summarize, Devops doesn't provide all the events. Also the complete DDL is sometimes useful if you want to be able to translate that into ClickHouse alter table syntax. That's available through Devops, but that's actually only available on a separate topic. So you cannot just have your sync connector read that topic. There's some extra processing you have to do. The other drawback is the one we just talked about is you might get out of order messages. Next slide, please. So this is our kind of direction in solving that problem, even though we have not fully solved it. So as I explained before, your normal records of all the changes would come in the table topic. Sync connector would read the table topic, but then the schema changes would come in a separate topic. Our idea is to have a separate standalone consumer that will read from the schema changes topic. But then when it does get a DDL, so for example, in this case, if it gets a truncate employees table, this DDL processor has to notify the task in the sync connector to stop processing. So we have to perform a coordination. And so some of it has to send a signal to these tasks. And then the task have to stop processing the records, and then the DDL processor has to execute the DDL statement. And then it has to let the task to resume processing the records. So there's a couple of options we've looked at. One is the sync connector out of the box has its own REST API. But then the REST API has drawbacks. The DDL processor can only communicate one way to the task. And then the other thing is the way sync connectors are designed they're actually just a bunch of threads. All the tasks are threads that are running in a process. So the worker is the process, and the tasks are multiple threads. So there needs to be some sort of a notification mechanism between the worker and the task. We're looking at gRPC as one way of coordination. So yeah, so this is a problem that we haven't solved. We definitely encourage everybody who is interested in this problem to kind of join our discussion threads in GitHub. And also everything is documented. We have all these diagrams documented in the GitHub project. So feel free to contribute, raise issues, try it out, and you can join the Altinity DB Slack channel and let us know if you have any questions. Next slide, please. Yeah, so these are links about where you can find the sync connector project, the ClickHouse project, the MyDumper is the other tool we looked at, and Percona is actively contributing to the MyDumper project. So instead of MySQL show, this is an alternative to perform the dumping of data from MySQL. Next slide, please. So next up in the sync connector, we are definitely looking at other databases. Postgres is one, MongoDB, SQL Server, Oracle. We're looking at supporting ClickHouse, shards, and replicas. The other interesting part is supporting transactions, which is kind of challenging in the way we have to handle DDL changes. Yeah, next slide. That's about it. Yeah, so you can find a lot of information on the GitHub project. As I said before, if you have any questions, yeah, feel free to Slack us or create issues on our GitHub project. Thank you.
Awesome. Thank you so much, Kanthi. Thank you, Vadim, for your contribution to this session. It was amazing. We seem to have one question in the Q&A section. We are right on time, but we'll take a minute to kind of look at the question. I'll go ahead and read out the question for Kanthi. In the validate data step, you mentioned an MD5 check on the MySQL and ClickHouse databases, but also you mentioned that data types are different between MySQL and ClickHouse. Wouldn't this difference between the database throw off MD5 result, or are you normalizing values somehow specifically for the MD5 calculation?
Yes, correct. We're actually doing the second one. So we are normalizing or changing the values during the MD5 calculation so that the data is the same. And that's why we have two separate Python tools, one for calculating the checksum for MD for MySQL, and one for calculating the checksum for ClickHouse.
Awesome, great. Thank you so much, Kanthi, for answering that question. If anyone else has any questions, please post it on the Q&A section. We'll stick around for another minute or two in case anyone wants to ask something. Yeah, thank you all for joining and thank you all for listening. No more questions? All right, great. Okay, I guess that is it. Thank you again, Kanthi, and thank you, Vadim, for this amazing talk. Once again, this is recorded, so we will be broadcasting it later on, either on YouTube or somewhere else. We'll figure it out. There should be slides available for download if you look into the Zoom events conference site. If you have any follow-up questions, please feel free to contact us at conference@altinity.com. That's again, conference, one word, @altinity.com. Thank you so much. Have a great rest of your day. Bye.
Wonderful. Bye.